In the Rail Lab, we focus on more fundamental research into AI. So we look at building new techniques, largely in the area of autonomous decision making. So how machines can make sequences of decisions, particularly over longer time horizons, to achieve some goal that's set out for them. An obvious example of this would be problems in robotics, where you might have a robot that you want to carry out a sequence of tasks, whether this is something like exploring an area or making you a cup of coffee. So a lot of the approaches that we take here are to isolate some component of what is important when we're reasoning and planning. So for example, we could say an important aspect when we're trying to solve problems would be skills, right? So you might have a skill for walking, you might have a skill for carrying something, you might have a skill for using a coffee machine or pouring milk. And if we can isolate those skills and do this in an autonomous way, so the system can figure out what skills need to be isolated and how to learn those skills, and in addition, when to use these skills, then that's really powerful. So one of the application areas that we've been looking at recently is in deploying robots into the Sterkfontein Caves, which is really useful for exploring the caves, for trying to understand the structure of the caves, and ideally in the long term helping to suggest places where maybe excavations could be conducted to help find interesting new fossils. And there's a whole lot of interesting robotics and machine learning challenges in these kinds of settings. Firstly, you need to be able to navigate the cave. This might involve, if you've got a legged robot, that it learns which is the appropriate walk to use in different situations to make sure it's stable enough so you don't slide down or fall over. It might have to identify which are dangerous areas to avoid. If there's a bit of a step down and it's got wheels, maybe it has to figure this out, that this could be a risk, and it should instead find another route to get to the bottom. Once you've got these navigation components, you then might have to coordinate between different robots. So it might be the case that you need a legged robot to explore one area and a wheeled robot to explore another area, or perhaps the wheeled robot can't get a good view of the scene that it's trying to film, and you need a drone to fly over with a torch attached to it to light up the area. So we look at questions of how these different robots can communicate to better navigate and map the space. And finally, there's a whole lot of imaging questions as well. How do we make sure that we can get the correct kinds of images coming out of this at high enough quality that it can be stitched together to give other scientists the sorts of information they need, or alternatively to be able to build interesting reconstructions for people to maybe walk through in a virtual reality type of setting. The caves are actually a Wits research site, and so this was a very natural collaboration and partnership. And subsequently this has grown, other faculty members and many students have become involved, and it's currently even being funded by National Geographic. It's amazing doing this work at Wits, where there's so much support in terms of everything from lab space to help in getting grants, to even other departments such as engineering, which has a number of other faculty that help us in our work, to other faculty within our own department that work on everything from optimization techniques to vision methods, and we can really bring all of this together to produce top quality research.